On the board here we have trig function y equals something sine. What's up, Adam? You look like you just had. You okay? Good. Okay, so we've got y equals something. If you pull your socks up, you won't be as cold. Okay, so we're recapping trig functions here. We've got the function in the general form y equals a sine x plus c plus d. Okay, a represents?
The dilation.
Yep, vertical dilation or amplitude. B represents, how do we? Horizontal dilation, not, which is our period. C represents with B. With B, C represents our horizontal shift, and D, vertical shift. Okay, so straight up I've asked you, and I've put black there, but sketch the sine curve y equals sine x, and most of us got that. Most of us understood the shape of that graph. Over here I then asked us in red, now I haven't got a red pen today, so I'm going to be doing it in dash blue, sine x plus pi on 2. And the way that we do that now, it's positive pi on 2, but our horizontal shift is negative, so I'm going to write over here. Horizontal shift equals negative c over b. So our b value is 1 in all of these graphs. Our c value is pi on 2, so we're taking it negative pi on 2, which means back pi on 2. So if I take this back to there, which is what I'm doing in my head, I basically put a dot on my graph and I mimic whatever is happening half a pi in front. So that one goes there, that one goes there, and we know that it would come back down because it's following that sine curve. Now if I do this in dash blue, I'm going to try and make it a curve. What does that look like? Well, I can prove that by going in coloured blue, full coloured blue, my cos function, which again we know does that. So you'll notice that our learning goal is about the fact that cos and sine are related. Both are oscillating functions. What is the difference?
Sine starts on the origin and the cos starts on the amplitude. Right.
Yeah, well if we think about back to our car circle, where is cos equal to 1? When does cos equal 1? On the x-axis, correct? When y equals 0 on the x-axis. So when sine equals 0, cos equals 1. Does that look like the case there? What happens at 90 degrees or pi on 2? Y equals 1, what does x equal? So this is sort of like a follow-on. It explains the stuff that we're doing the other day in the car circle. The last one here, so we've got our cos function, and again what are we doing? We're taking it to the left or to the right?
Left.
By a value of?
Negative half pi.
Yep, pi on 2. So I say, well, where does this function, the blue function, what does that equal at pi on 2? And I put a little dot on my graph. What about at pi? Where is it? Top, middle, bottom? The blue one is at the bottom. What about at 3 pi on 2? Okay, and then we connect our dots, the dash dots. No, you don't. I was just trying to show where it goes afterwards. Okay, if you just did the 2 pi, that's fine. Now, what does that look like? A negative sign. Good. Happy with that? So the nature of these oscillating functions is anything that is oscillating, you can translate it horizontally and turn it into another oscillating function, whether that is sine, whether that is cos, whether that's negative sine, whether it's negative cos. If I wanted to get, let's say I wanted to turn this sine function into a negative cos function, what would I do? So I'll draw a new sine function up over here. So here's my sine function. If I wanted to turn that into a negative cos, so I want my function to start at the bottom and work its way up, go through there. How far would I need to shift it? To the left, how many? So this is pi on 2. That's pi. That's 3 pi on 2. And that's pi, 2 pi, sorry. How far would I need to shift this function to the left to get it to equal negative pi, the negative cos function? Pi, just pi. If I take that back pi, doesn't it start here?
2 pi.
Well, doesn't 2 pi start there?
What are you trying to lie on to?
So I want this function to look like this.
3 pi.
3 pi on 2, correct?
Yep.
It starts there. So I take that back there, which is equal to y equals sine x plus 3 pi on 2.
So can you just shift it to the right?
I could. That was my next point. That could also be y equals sine x minus pi on 2. I'm shifting it to the right, pi on 2. Because if I continue that there, that's where it's going to go. Very good, Lockie. You took the words out of my mouth. So with your horizontal shifts, sine and cos are very, very related. Yes?
Can you have it?
In a second. Needs to cool down first. Happy with that?
Yeah.
We'll do some derivatives.